Hello my dear students, good morning. I hope you are all safe and you are practicing well. And now we will continue the class with haloalkanes and haloarenes with the chemical properties of haloalkanes. Okay, so haloalkanes undergo here some substitution reactions. What kind of substitution reactions means? They will undergo nucleophilic substitution reactions. As we discussed, the particular nucleophilic substitution reactions two types. One is SN1 and SN2. Here the nucleophile is particularly, this is X leaving group, as X minus it will go out, so that by using this kind of reagents like KOH and moist AZ2O and RONA, sodium alkoxide, and here KCN, here AgCN, KNO2, AgNO2, CH3COO, Ag and NH3. These will replace X. So who will replace? Complete KOH will replace? No. Here OH minus will replace. Here, yes, again OH will come here. So why I'll tell you, OH minus will replace here also. And here OR will replace OR minus. Here CN minus will replace, carbon will form a bond. And here NC will replace X, so that means nitrogen will form a bond. So this CN is called ambident nucleophile. As you know, in complex compounds and many times in organic chemistry also we discussed, ambident means in only one nucleophile two atoms can donate. Here carbon can donate, here nitrogen can donate electron pair. So here when you are using KCN, carbon is going to form bond with this carbon, and when you are using AgCN, nitrogen will form bond. Remember, when silver salt given, nitrogen will form bond here. Remember that. Here ONO actually, ONO. So what I am giving star, that will attach to carbon. Okay. So here NO2 actually. So NO2 minus, ONO minus, CN minus, NC minus, nitrogen will form bond. Remember, when you have a silver, then nitrogen will form bond with carbon. Remember like that. Okay. And here what you have, CH3COO minus here, and here NH2 group, HCl will go H plus and X minus. So what is X here? X can be like a chlorine and bromine and iodine, of course fluorine also, but among them who can react fast, as I said, I minus is the best leaving group, then Br minus, then Cl minus, and least is F minus. Okay, because of very small, it has a smaller bond length, certainly shorter bond length, when it is there, bond energy is more required. So I minus is the best leaving group. So if it is iodine, that can react fast. So this is order of leaving group I written already, I given already. Okay, so what kind of substitution reactions means? These are nucleophilic substitution reactions on haloalkanes. Now you can write products, I think so. So what will be the product here? See, here you have CH3CH2X, X replaced by OH. So that means you are having CH3CH2OH. You are having, see, these are very, very important for us. And along with that, KX. So KC, if it is chlorine, KCl will go out like that. Got it clearly? Now if you are using moist AZ2, that is very important. When you are using moist AZ2, that means AZ2O with water. Certainly 2 moles of AgOH will come. So what will be the nucleophile here? OH minus. So OH minus is the nucleophile. That means what you will have here? CH3, CH2, OH only, alcohol. So what I am giving conclusion here, when you are using this moist AZ2O or else aqueous KOH, then alkyl halides turns to what? Alcohols. Correct, sir? So this is one of the preparation of alcohol. So in alcohols chapter we have preparations. There we have no need to learn separately. Okay, so here you have 2. So certainly what will be the remaining? AgX. So 2 moles of AgX you are having. So then 2 moles of this we have taken, no sir? Yes. So but please, my request, don't try to remember like that. See, alkyl halide when react with moist Ag2O, alcohol is the product. Sir, the reaction happen by SN1 or SN2? That depends on what nature of alkyl halide. If alkyl halide is a super primary or primary SN2, if alkyl halide is a benzyl, allyl or tertiary alkyl halide, then by SN1 mechanism. This is very, very important for us. Got it, sir? So next here alcohol formation. Next, when react with RONA, when this RONA, when react with alkyl halide, then the reaction is called Williamson synthesis. What synthesis that is called? Williamson's synthesis that is. What is Williamson synthesis? Means it is a preparation of ethers. Preparation of what? Ethers. How? When alkyl halide react with the sodium alkoxide, RONA, then what will get product? Can you guess? CH3, CH2OR. So is it ether? Yes, it's ether preparation. So here what happens? Sodium and X will remove as NaX. Commonly I am writing all properties at one place. But in Williamson synthesis, there is an exceptional case that you have to know. What is that exceptional case? Here, if the alkyl halide is tertiary, like this. If you have a chlorine, suppose here, and NaOC2H5 you have, then what happened actually? This NaCl will go. Okay, in Williamson synthesis, what happened? NaCl will go. So Williamson synthesis, dry ether is required, and in presence of acid, like that you will take. Now what you are having here? CH3C and CH3 and double bond CH2. That means what you are having? Alkene here, alkene. This is exceptional case. NaCl won't go. Sorry, if I am writing like this, this is wrong. So this won't happen. Few people will think NaCl will go, then instead of Cl, OC2H5 will come, like that they will think. No, as a tertiary carbocation is more stable, Cl will come and H will come from there. So minus HCl. This happens. So here NaOC2H5 just act as a solvent. When I repeat, if alkyl halide is a tertiary, then when you are treating with the sodium alkoxide, or here sodium ethoxide I taken, and when these two reacted, what you expect? By removing NaCl, you expect OC2H5 instead of Cl. That's not happening actually. So what happening? Alkene is forming. So by removing hydrogen from here and Cl from here, so then double bond must be here, no? So they will ask, but all are methyl groups. You can remove from anywhere. Like you can remove from here, you can remove from here, you can remove from here. What you can remove? Hydrogen. So I removed suppose from here, then double bond I have here. So Cl from here, this one. So here the most exceptional one, and comparison I am giving you. Now suppose CH3, CH2, ONA, no. Then it will be same. CH3, CH2Cl, then NaO, CH3, CH3 and CH3. What do you observe? What do you observe the difference? Okay, did you find the difference? Here alkyl halide is tertiary, but here sodium alkoxide is tertiary. Then ether only will come. Okay, because here stable carbocation is not forming. So here NaCl only will go. Understanding? So you have to write this, what I am saying. If sodium alkoxide is a tertiary ether, if alkyl halide is tertiary and treating with the sodium alkoxide, then alkene. Of course here butene. Okay, of course, 2-methylpropene, that you can say, but generally I said isobutene like that. Okay, now what will be the product here? So means like CH3 and CH2 and O, C, CH3 and CH3 and CH3 here you have. Got it, sir, everyone? So in Williamson synthesis generally I given, so formation of ether you have actually. So alkyl halide when react with KCl you have ether with NaX, okay, and ether won't form in Williamson synthesis. Williamson synthesis, how do I identify? Alkyl halide must react with sodium alkoxide. Sodium alkoxide, oxide O. Okay, alkoxide means OR, alkoxy group. Okay, so sodium alkoxide given, alkyl halide tertiary given. Here one thing must come, like yes, alkene is the product because alkyl halide is tertiary. So if alkyl halide is the primary and here sodium alkoxide is a tertiary, then no way, no problem for you, sorry, and then you will get ether. What do you have here? Ether only. This is very, very important. Please note it down. And come to this, it's very simple. When you are using KCN, then cyanide, carbon will form bond. So you can expect product here, CH3 and CH2, CN, C triple bond N. Okay, so here who is forming bond? Carbon. Carbon is forming bond. So K plus and X minus will remove as KX. If it is chlorine, KCl. So what is the reason behind it? Because only one reason. Here I will write here. This is K plus and C triple bond N. So minus, like this exists. Okay, so here it's purely ionic. KCl is ionic. KCl is ionic. So it can easily dissociate, so that C triple bond N, negative charge is more stable on carbon because nitrogen trivalency is more stable instead of tetravalency. So negative charge is more stable on carbon. That's why you have a negative charge on carbon. That's why here who is forming bond? Carbon there. But whereas in particular this condition, AgCN when you are using, this silver is having covalent bond with carbon actually. That's why carbon is restricted to form bond, so that nitrogen will form bond with this carbon. Got it what I am saying? So that here the product is CH3, CH2, NCN triple bond C. So what you are having here? Isocyanide. Isocyanide. Correct? What is the reason behind it? Your AgC triple bond N. So what nature it is? Covalent nature. So carbon is very busy here. So carbon cannot form bond. Certainly, who is attacking here? Nitrogen is attacking. Because carbon is in bond with silver. It's having some sharing nature between this carbon and silver, so that nitrogen is going to form a bond. But simply remember that reason why I said they can ask question in the particular way. They are like which of the following is correct, which of the following is wrong, like that. At that time they can give a statement like this: CN with silver in AgCN, that is covalent, that's why nitrogen is forming. That is a correct statement or wrong statement. Maybe they can ask. So that's why I given. But remember, when silver given, nitrogen is forming bond. Remember this. Now here the product is not nitrogen, it is K. So some other means oxygen will form bond. Not K plus, some other means K. No, sir, don't ask me. It is a nucleophilic substitution. So that here what will be the product? Can you guess? CH3, CH2, ONO. Okay, ON double bond O actually, ONO. So here who is forming bond? Oxygen. Same story here. So K plus NO2 minus. So here like this, K plus and ON double bond O, nitrogen 3 bond stable. So oxygen negative charge, because this oxygen have only one bond, no? So negative charge is more stable. So oxygen is forming bond here. Oxygen is forming bond here with carbon. Got it, sir? Now come to this here with silver. What you are having here? CH3, CH2, NO2 only. N double bond O, single bond O. So why NO2? Because I write here AgNO2 means Ag double bond O and like this. Oxygen is busy. O N double bond O. So here oxygen have what nature with silver covalent nature. So can it form bond? No. That's why nitrogen is forming bond. When you are using AgNO2, who is forming bond? Nitrogen. Got it? Here same story. Here X will go and silver will go. AgCN. So ester will form. What is that? Ester. So what is ester formation? CH. First you can write this. CH3, COO and CH2, CH3. It is ester. CH3, C double bond O, CH2, CH3. In that way also you can call. Or CH3, CH2, O, C double bond O, C double bond O, CH3. Ester it is. Why this is called ester, understood? What is the formula? You can represent CH3, C double bond O. Now this ethyl group. That means CH2, CH3. So what was removed from in previous year? Silver you have, here X you have, so AgX removed. Got it? Now come to this, very simple. As I said in previous also, HX will remove, so that you will get CH3, CH2, NH2. This reaction can be repeated. This is called Hoffman homonolysis. Means X replaced by amine group. X replaced by amine group. So you will have the CH3, CH2, NH2 like this. So these are the most important nucleophilic substitution reaction. So I'll continue this Hoffman homonolysis reaction because that is a preparation of amines for us. Certainly this reaction will come in what? Amines. This reaction will come in carboxylic acids. Getting what I am saying? These reactions will come in carboxylic acids because cyanides on hydrolysis you will get carboxylic acids. Write down this. You will have in carboxylic acid preparation. Isocyanides on reduction you will get secondary amines. Write down these 2 points. Those are useful to you. Okay. And few more reactions. As I said, I'll continue with this Hoffman homonolysis. Okay, you please write it down. So I'll continue with that. Please have a screenshot so that you will have full clarity. So this exceptional case in Williamson synthesis, I hope you understood. So I will go for Hoffman homonolysis. So that particular reaction, repeatedly that particular amine will react with alkyl halide. That happens actually. So that I'll show you how. Okay. So as I said, when you are using KNO2 and AgNO2, what happens? Set up. Okay. If I use KCN, AgCN, what happened? Okay. And in Williamson synthesis, what we use? Alkyl halide with sodium alkoxide. In Williamson synthesis, if alkyl halide is a tertiary, alkene. In Williamson synthesis, if sodium alkoxide is tertiary, no problem, ether is the product. Got it, sir? Now we will have one more, the most beautiful thing, that is what reaction? Hoffman's homonolysis. Okay, spelling first question. Okay, what is the spelling of Hoffman homonolysis in NEET exam? Nobody will ask. Don't worry and don't concentrate on spellings. What is Hoffman homonolysis? Alkyl halide with KCN, what happened? Alkyl halide with silver oxide, if it is moist, What is the product? Like that only you have to remember. Don't by have a single reaction. Alkyl halide with moist H2O alcohol. Like that. Okay. I'll tell you differences when you are using dry Ag2O. What is the product? That also I'll tell you so that you can compare both later on. Okay. What I'm saying, understanding? Alkyl halide with moist Ag2O alcohol, but alkyl halide with the dry Ag2O, what will be the product? I'll tell you later after this. Okay. So as I said in previous, suppose you are using CH3, CH2, Cl. When you are using NH3, that means you are having CH3, CH2, NH2 plus HCl you are having, right? You are having what? HCl, right? Now, here this particular nitrogen can form 4 bonds because nitrogen maximum covalence is 4. Nitrogen, 5th A group, 8 minus 5 means nitrogen general valence is 3, 8 minus 5. But by using lone pair, nitrogen can have 4 bonds. Getting what I am saying? That's why here this nitrogen has now 3 bonds, right? So that one ethyl group you have and 2 hydrogens you have. That means 2 more hydrogens can be replaced by this kind of ethyl groups, right or not? Initially first. So here what happened? Tell me. This H, N, H and H. So this one of the hydrogen just bonded with the chlorine and removed as HCl. That means you are having CH3CH2 NH2. Got it, everyone? Okay. Like that, 2 more times the same reaction can happen? Of course, you cannot say right now. So H can combine with 1 more chlorine which is present in alkyl halide. So like 1 more hydrogen can combine with 1 more ethyl chloride. So that 3 ethyl chlorides can react because 3 hydrogens are there in ammonia. But you said 4 times, no sir. Yes, nitrogen has a lone pair. So by using lone pair, 1 more alkyl halide can form bond. So with ammonia, there can 4 ammonia molecules react. So why I am saying this? Number of alkyl halides can be react with ammonia means you have to say 4 moles. How many moles? 4 moles. I'll show you here. So what happens? One time over, 1 mole of alkyl halide. Now second time. Now same story. CH3, CH2, NH2. This formula one I am saying. This one I written. Now Cl, CH2 and CH3. So that what happened? CH3, CH2, N, CH2, CH3. 2 times. So that 1 more hydrogen is there. Right? So what happened? Here 1 hydrogen and Cl. So removed as HCl. 2 times over. First time. Okay. 1 more of ethyl chloride react with ammonia. 1 hydrogen removed from ammonia. Now primary amine was formed. This is primary amine. This primary amine again react with ethyl chloride, chlorine and 1 hydrogen from this amine, removed as HCl. Then you got secondary amine. Now what happens? This secondary amine, that means CH3, CH2, N and CH2, CH3 and H. This can react with 1 more mole of ethyl chloride. I will write C2H5HCl. Then what happened? Again this H and this Cl will go. Correct? Sir, understanding what I am saying? So I am not using this. Okay. So now what can remove? HCl can remove. So that what can be the product here? CH3CH2. I will write as C2H5. I will write as C2H5. N and C2H5. N C2H5. Lone pair. Now, sir, hydrogen not there, no sir. HCl removal not possible, no sir. Yes, but it forms a quaternary ammonium salt. Quater means 4. Quaternary ammonium salt will form. This can react with 1 more mole of ethyl chloride. That means what you have? C2H5 and C2H5 and C2H5. It's having lone pair. And now Cl, C2, C2H5. So this is one of the important preparation in amines. So here if you learn, there it will be easy so that you can save time there. Maybe you feel, why he is explaining this much? Because you have this in amines. That's why I am explaining. Please, okay, be patient. And here what happened? This Cl cannot go now. So it will remove as Cl minus. But this carbon having positive charge. This positive charge will be attacked by lone pair and form dative bond. Okay, so that what you have here, final product and C2H5 and N and C2H5 and C2H5 and C2H5 and nitrogen has positive charge. So why nitrogen has a positive charge? So here means it donated lone pair to this carbon. Now here you have Cl minus. This is salt. What salt? Quaternary ammonium salt. Quaternary ammonium. I don't have a place, that's why I simply written quaternary ammonium salt. Got it, sir? So this is called Hoffman ammonolysis. I'll give you few more reactions. Elimination reactions. Elimination reactions. Mainly I'll give you two here. Ethyl chloride, suppose CH3, CH2, Cl, when you are treating with aqueous KOH, the product is substitution actually, so alcohol is the product. So you will have CH3 and CH2, OH you are having. Comparison I will give you. Of course, I am not mad fellow and this is not elimination reaction. This is a substitution reaction. When you are using aqueous KOH, what happened? K plus and Cl minus gone and you have alcohol there. And next, if I will give you the same kind, but I'll made a one small change. And when I'm using alcoholic KOH, when I'm using alcoholic KOH, this is the most important thing for you. Alcoholic KOH, alcoholic. Then what happened here? Here you will have CH2 double bond CH2. So here it is eliminating reagent. So HCl was removed. Dehydrohallucination this is called. This particular reaction is called dehydrohallucination. Dehydrohallucination. Alkene. Correct? Same, I will give you here one more, the most important thing. CH3, CH2, Cl. Okay. When you are using Mr. dry Ag2O, dry Ag2O, here the product is not alcohol. Here what happened? Silver chloride will go. Then ether is the product. Then what is the product, sir? Ether. That means how you have tried this Ag2O, dry given like this, dry Ag2O means AgOAg and plus I write plus. Okay? Plus Cl, CH2 and CH3. Then what happened? AgCl will go and AgCl will go. Okay, so AgCl 2 moles removed. How many moles removed? 2 moles of AgCl removed. Sir, in previous Ag2O you given alcohol, no sir, but here you given ether. What is the reason? Here no water. It is a dry Ag2O. There I was given moist Ag2O. Then alcohol is the product. Hope you understood. Now here you have the product CH3 and CH2O. CH2 and CH3. Please, what you have here? Ether. What is the product here? Ether, the most important thing. I think you understood this Hoffman ammonolysis and all. Okay, I'll conclude. In previous, as I given Finkelstein reaction, That is also like a property because one halogen replaced by other. Okay, so later on, if you see this kind of elimination, you have by Sage-Joff rule. What is that Sage-Joff rule? You have to remove, this is elimination, no? You have to remove the beta hydrogen from the beta carbon which have less number of hydrogens. So like Markovnikov rule, you have to add the negative species to the double bonded carbon which have less number of hydrogens. Like that, in this particular, what rule I said? Okay, Sage-Joff's rule. In this Sage-Joff rule, you have to remember one thing, that removal of particular halogen or else negative species. Okay, removal of beta hydrogen should happen from the beta carbon actually, which have more number of hydrogens or less number of hydrogens. And when I am using this alcoholic KOH. Okay, so here what happened? So as I said, when you are using alcoholic KOH, dehydrohalogenation takes place. So here you have chlorine here. Chlorine we have to remove. With whom? With one of the hydrogen. From what carbon? From adjacent carbon. Adjacent carbon you have two. This is one adjacent carbon and this is another adjacent carbon. Actually, the particular functional group which is attached, that particular carbon is called alpha. The carbon who is directly attached to functional group or substitute, that is alpha. And alpha next carbon is beta. This alpha next carbon is beta or beta dash. So according to Sage-Joff rule, you have to remove hydrogen from the beta carbon which have less number of hydrogens. Otherwise, in elimination, you should have product, okay, with the double bond consist of more branches. Double bond with more branches, that is more stable. See, best thing, here if you have a double bond here particularly, you have two methyl groups. But here if you have a double bond, this side no alkyl group, here less substituent we call, because this will be one branch and here you don't have any branch. So here if you have a double bond, less branching. Here if you have a double bond, more branching. Understanding? So here I have two bodyguards. Here I have two bodyguards I have. Okay, I am very rich, I am bombarding. So then I have full security. Correct? I am here, four bodyguards right side only. So this side nobody. So somebody can attack from this side. So I will become unstable. So what I am saying, in that way, double bond should have more branches, both sides or top and bottom. Then that will have more stability. So here what happens? So you have to remove particular beta hydrogen from the beta carbon which have less number of hydrogens. That is called, what we call Sage-Joff rule. Then what do you have here? CH3 and CH and double bond CH and CH3. And one more possibility, you can remove hydrogen from here. Of course, this is major. And the minor product is, you can remove beta hydrogen from this beta carbon. So then you have a product CH3 and CH2 and CH and double bond CH2, and this is a minor product. Understood, sir, everyone? And next we have to discuss one more important reaction, that is formation of Grignard reagent. What is the Grignard reagent? We have many actually reactions. Okay, so those also we will discuss. Grignard reagent when react with alcohol, Grignard reagent with what we call aldehydes and ketones. What happens? Those are important. So Grignard reagent is RMgX. What is the meaning of RMgX? Alkyl magnesium halide. So it's R minus Mg plus. Okay. So how you have this particular formation of Grignard reaction? Suppose I am taking CH3CH2 RMgX. Suppose if I am taking chlorine, X is halogen, right? Chlorine, bromine, iodine, like that. So when I am using magnesium in presence of Mr. Dry ether, then what happened between these two? Of course, it is already have a partial charges. This has what charge? Delta minus actually. This has what charge? Delta plus. What is the use of magnesium? Metal. Metal donate electrons or not? Yes. So this metal donate electrons to this. So this way, this positive will become negative. Mg plus 2, because the magnesium will lose 2 electrons. Magnesium can lose 2 electrons because magnesium configuration, if you see 1s2, 2s2, 2p6, 3s2, it can lose 2 electrons from 3s. Of course, this magnesium is 2a group element, it can lose 2 electrons. Correct or not? So here what you have means CH3, CH2 and MgCl. You have CH3, CH2 minus and Mg plus. Got it? So this is the most important thing. Hope you understood. CH3, CH2 minus and MgCl plus. Why Mg plus? Sir, Mg plus 2 you said. No sir. Now you written Mg plus as a mad fellow. Are you thinking? MgCl plus means again it will dissociate as Mg plus 2 and Cl minus. If combined, that will be again Mg plus and Cl. So magnesium plus 2 actually their charge. That can be a question. What will be the charge of magnesium? In MgCl, the charge is plus 1, but overall charge of magnesium plus 2. Like that you have to remember. This is formation of Grignard reagent. Next, this actually alkyl halide CH3, CH2, Cl. These are used to increase the number of carbons in alkynes actually. Alkynes and alkenes also. When you are taking sodium alkoxide like NaC triple bond CH like this, then this Na plus and Cl minus will remove as NaCl. So minus NaCl you are having there. So what you have a product there? CH3, CH2, C triple bond CH. This is one of the property you have to remember. Alkyl halides use it to increase the number of carbon atoms in alkenes and alkynes. Okay. For that, what you have to take? Metallic things you have means metallic alkenes or alkynes you have to take. Okay. I forgot to tell you, if they give in previous I was given aqueous KOH, right? So aqueous KSH also same thing. Means instead of OH, what will substitute? SH will substitute. Understanding what I am saying? Aqueous KOH with alkyl halide, alcohol is forming. Here thiol will come. So I will give one reaction. I forgot to tell you this reaction actually. So I will write that reaction. See, suppose RCl when react with aqueous KOH, the product is ROH I written, right? Now instead of that RSH I am writing. So RSH. This is called thiol. What is that? Thiol. Same story, KCl. Okay, same alkaline. If you are taking alkaline alcoholic KOH, alcoholic KSH, then elimination reaction. Both are very, very important actually. So these are the most important chemical properties of haloalkanes. Okay, so now actually we have to discuss one more important reaction, that is Wood's reaction. That you know already. Wood's reaction is used to preparation of alkanes. If I am explaining here, there you have no need to worry in hydrocarbons first year. So simply one reaction I will give you, that is Wood's reaction and Wood's fatigue reaction. Okay, and Fittig reaction. Differences I will give you. Woods reaction means alkyl halide CH3 CH2X. Okay, suppose Cl when react with Na and Cl CH2 CH3. This is called Woods reaction. What happens here? NaCl will go. Then what happens? Here you will have CH3 CH2 CH2 CH3. Do you know? Woods reaction is used to prepare only what? Hydrocarbons with even number of carbons. That is the most important thing. Odd number, why you can't get? You can get odd number, but separation is difficult. That's why this Woods reaction is suitable to prepare only alkanes with even number of carbons. You will get more elaborately full information in hydrocarbons. So here if you learn all these reactions, so next chapters will be easy, because here you are having alcohols, here you are having amines, here you are having ethers. So try to understand this. That's why I am taking more time for this. Definitely, if required, one video extra only I will do, not a problem, but try to understand everything, because it is our second class only here. Okay, so this is Woods reaction. Next, the most important, what is that? Woods fitting. Woods Fittig reaction. Fittig, TT, this is. Very simple. Both alkyl halide reacted with sodium. See, one is ethyl chloride, one is methyl chloride. Can we take? Then you will get propane, no sir, odd number, no sir. You may think. There are three types of products will come. Okay, all three separation is difficult because they are they are having same boiling points. So separation is difficult. Understanding? That's why Woods reaction is used to prepare alkanes with even number of carbons. This point you write down, please. Woods fitting reaction means in Woods reaction ethyl chloride. But in Woods fitting, one is alkyl halide, one is aryl halide. So aryl halides are also included here. That's why I am explaining. Suppose CH3, CH2, Cl and Na, and here I am taking benzene like this. Then what you will have? What do you have? NaCl will go, right? But this is difficult because this chlorine and this carbon have double bond character. So what will be the product here? Very simple. CH3 and CH2, C6H5. Ethyl. Okay, benzene. Now what do you have? Or phenylethane, we call IUPAC name. And 2 moles of NaCl. Okay. What is just Fittig reaction? Fittig reaction means very simple. Both are aryl halides you have to take. Both are alkyl halide with sodium, Woods. Alkyl halide and aryl halide with sodium, Woods Fittig. This is aryl halide. This is aryl halide. Now both are aryl halide. Now I am taking benzene, chlorobenzene, and 2 moles. And here I am taking Cl. Okay. Now this NaCl will go. Now biphenyl you are having. So NaCl will go, then biphenyl. What is a biphenyl means? 2 benzene rings like this. C6H5 single bond like this. This is called biphenyl. Okay. So this is about Woods fitting. Next, alkyl halide. You know this Friedel-Crafts alkylation. This also happens. This is also like electrophilic substitution reaction. Suppose CH3, CH2, Cl when react with benzene in presence of anhydrous AlCl. If you take it methyl chloride, then this will be like CH2 plus and Cl minus. So it is electrophilic substitution. Then what is the product here? C6H5 and here you are having CH2, CH3. If you are having methyl, just methyl chloride. But in this kind of reaction, one small exception. Suppose if you are having this CH3, CH2, CH3. First you write on this. Okay, then what happens? Suppose here you have CH2Cl you have. This carbon won't form bond with benzene. This carbon will form bond because secondary is more stable. Then here instead this can form bonds. So both are same set. This is attached to one carbon and this also attached to one carbon. But the same reaction, if you see, if I take propyl chloride instead of this, if what I have to consider, previously you have right and this again you have right 2 times. If I am taking this CH3, CH2, CH2Cl with benzene, the product is this one. Means actually where we expect this benzene bond, at this carbon we expect bond with benzene. But benzene is forming bond with this carbon because this carbon is secondary, that is more stable. So these are about alkyl halides and aryl halides. Aryl halides just electrophilic substitution reactions, just a matter of 5 minutes. I'll write at one place, then very next minute I'll start alcohols. Okay sir, and as I said, write down every reaction and practice 10 times like that, and still if you have doubt please ask me, and please take care, okay, about yourself. Okay, your health is very important, and be confident and practice all these things. Definitely you can understand. Thank you very much.